Welcome to EPG Pathshala lecture series on computer science. In this module on data analytics, we will be discussing about neural networks, which is one another analytical technique used for analysis. The learning objectives of this modules are: first, to understand the basics of neural networks, followed by know the applications of neural networks. The overview of this particular module is like this. First, let us understand what is neural network by means of a simple introduction, followed by the history of neural networks, how neural networks was created and evolved over a period of time, followed by models highlighting the basic elements of neural networks, followed by applications of neural networks. To start with, we should first understand the basic computer modeling towards computational approaches. Normally, computer modeling approach to computations is loosely based on architecture of the brain, and this is especially with respect to neural networks. There are actually many such models that are available, but all these models in general will have the following components. The first important component is multiple individual nodes or units that operate as the same as the brain units, which are basically the neurons, and all these units actually operate at the same point of time, that is in parallel. The second important component of any neural network based model is the network itself, because every node in the network must be interconnected, and therefore, the network structure itself forms the second important component. Thirdly, the information that is stored is in distributed fashion, because you have multiple units, and on all the multiple units these informations are distributed, and the links that connect to these nodes help in terms of exchanging these data across various nodes. And the learning as part of any neural network occurs with a small or a gradual change in the connection strength, and this change is going to be very minimal for each and every iteration, but over a period of various iterations there will be a significant amount of change in terms of the link strength or the connection strength. Now, let us understand the history of neural network. Actually speaking, neural networks started as early as in the 1950s, but it became very popular only in 1980s. Initially, there was a framework that was created for parallel distributed processing, and this was used for exploring the microstructure of cognition, and this was created by Rumelhart, Hempton and McClelland, and this was created in 1980s. This work actually kick-started the applications of neural networks in various domains, and in 90s there was a significant level of work or research happening with respect to neural networks and its application. Hundreds of variants of neural networks and its design came into picture, less a model of an actual brain than a useful tool, but it was still there was some debate about the application of neural network in different applications. There are variety of applications in which neural networks find itself suitably fitting into. Few examples are handwriting. Suppose you want to come up with an automatic handwriting recognition and understand what exactly is written over say an e-pad, then neural network may be applied there for recognizing the handwriting. Face as well as speech recognitions or other domains where neural network plays a vital role. Then when we have self-driving vehicles have to learn on themselves, and the environment in which self-driven vehicles are highly erroneous. In other words, the inputs to these vehicles will be error prone. When you have lot of error prone data incoming to the environment, then neural network is one best application that may handle such erroneous or noisy data. So, self-driven vehicle is another application where neural network is adopted, and there are various models that are created for reading, sentence production, and then even for understanding what is happening in during dreams. So, these are all various applications where neural network is widely used. When we talk about the history, as I already mentioned, in 1890s, William James was the first person who defined a neuronal process of learning. Then in 1943, 1954 and 1958, there were significant outcomes coming out of research based on neural network. McCullough and Pitt actually came up with the earliest mathematical models for defining neural networks. Donald Hebb and IBM research actually came up with the earliest simulation for neural networks, and Frank Rosenblatt came up with the concept of perceptron, and perceptron is the one which is very actively used in the neural network domain. Then in the late 60s, the research associated with neural network actually was a bit slow, but still then perceptron concepts were widely used for the purpose of various applications in spite of its limitations. Then in early 1980s and 1990s, multi-layer based neural network approaches were defined and they were widely used for multidisciplinary research. And in 1980s and late 1980s only, actual and voluminous amount of research happened with respect to neural networks. Now let us understand what is a neuron, how neural networks are designed based on neuron. Neuron is actually a biological concept and it is one significant unit of the brain. There are different or multiple levels of neurons actually available in the brain, but in spite of these heterogeneity and multiple levels of neurons which is available in the brain, when you take one fundamental unit of the brain called the neuron actually has the following three parts: the head, the body and then the tail. The head is actually the place where neuron receives inputs from adjacent neurons. The head is the place where multiple layers of neurons will get connected to another neuron, and through this particular point only the stimulants are transmitted. So, a neuron receives input from other neurons only through the head. Now, in the head and in the tail, you have various points which link to other tails or heads of other neurons, and this point where one neuron get connected to other neuron is called as a synapse. So, the input coming from one layer of neuron to the other neuron or other layer of neuron is only via the synapse. When multiple inputs are given to a single neuron or say another layer of neuron, the inputs need to be summed. So, the inputs are normally summed or approximately summed for the purpose of transmitting it to the next layer. Whenever the input of the previous layer of neurons exceed a particular threshold, then the neuron which is going to transmit the input to the next layer must either amplify the signal or de-amplify the signal according to the strength of the signal, that is the input signal. So, you will have to have an amplification or a de-amplification quotient that will help in safely transmitting the signals from one layer to another layer. So, this is how neurons in a brain normally work. Having understood what is a neuron, the fundamental unit, then let us understand how learning happens in the brain. Brain actually learns by means of the strengths between neuron. I told you in the previous slide that one layer of neuron get connected to another layer of neuron by means of a synaptical link, and learning is actually based on the weight associated with this link. Creating and deleting connections is the process by which brain learns. So, either a new connectivity or a new synaptical link may be created or any existing old synaptical link may be deleted, and this indicates whether a brain learns or not. Actually, there is a postulate called Hebb's postulate which talks about Hebbian, which is also called as Hebbian learning, that tells exactly how brain learns. Suppose when there is an axon of cell A which wants to communicate to another cell, that is axon of cell A wants to excite another cell say B, then there must be some metabolic change that is happening at that point of time, which indicates one cell fires the other cell. So, therefore, some kind of neurotransmitter substance will be there for the purpose of taking the signals via the body of a neuron and then pushing it to the next layer. The long term potentiation, in short called as LTP, is actually the basis for learning and memory, the cellular basis for learning and memory. LTP is a long lasting strengthening of the connection between two nerve cells, which is done in response to stimulations of these cells. This activity was discovered in many regions of the cortex. So, putting together, when one neuron wants to communicate to another set of neuron, the head of a neuron will receive the input signal from another set of neurons, push it via the body of that neuron and then push it to the next layer via the tail of the neuron. So, the connecting links are called as dendrites, and one dendrite of a neuron and another dendrite of another neuron connects through a point called synaptical point. Let us understand what is the difference between neural networks and general computers. When we talk about digital computers, what kind of reasoning actually happens in digital computer is, it is a deductive reasoning. Deductive means there will be lots of rules will have an LHS and RHS. Based on any rule that satisfies the LHS will be triggered, and accordingly it produces an output. But this is not the same in case of neural network based learning. In neural network based learning, it is going to be an inductive reasoning. In inductive reasoning, given an input and output data, that is, we have training examples, then we will have to construct the rules. So, in general digital computer, rules are existing, but in neural network based computational environment, rules are generated. Computationally speaking, digital computers are centralized, they are synchronous and serial in terms of executing of tasks, but in case of neural networks, computation is going to be collective, it is asynchronous and it is parallel. In digital computers are applicable if there is a well defined rule set and with precise input data, but here in neural network based environment, even if rules are not available, neural networks can handle any kind of data, even if it is going to be noisy or say partial, and accordingly create respective outputs. The output of digital computers are exact, but in neural network based computational environment, the outputs are going to be inexact, and moreover it is dynamic in nature, but in digital computer it is going to be static in nature. Based on these differences, you can understand the working of a general computer and a neural network based environment or a computational environment. Now, what are the various fields that are related with neural networks? The first place where you can connect to is the general scientist or the computer scientist. Computer scientists actually find lots of way by which properties of non-symbolic information processing with the help of neural networks are done, and this is used for the purpose of learning in general by machines. So, computer scientists actually widely make use of neural networks for the purpose of creating various learning models. Secondly, in the field of statistics, many statistical researchers actually make use of neural networks as a flexible, non-linear, regressive and classification models, because as part of statistics there may be lot of surveys conducted. We may be in a position to identify what are the parameters in those surveys that are connected or related with each other or correlated with each other. Therefore, a regression model may be defined and accordingly data may be understood. Engineers in general make use of or exploit neural networks for the purpose of various research areas like signal processing and automatic controls, because in signal processing and automatic control environments, the input data in many scenario is not clearly defined and many times it is erroneous in nature. So, when you want to handle erroneous data, neural network comes first. Cognitive scientists are the best one who makes use of neural networks. So, with the help of neural networks, cognitive scientists provide various models or create various models of thinking and consciousness. Neuropsychologists, physicists, biologists and philosophers also make use of neural networks for defining various brain functions, understanding the way how elements, materials behave, interact and identify nuclear sequences. philosophers at last make use of neural network for understanding the linkage between various individuals as well as logical reasoning purposes. Now, let us understand what is a perceptron from a neural network perspective. Actually, this perceptron is a connectedness networks. In other words, you will be having multiple nodes. These nodes will be interconnected by means of links. This is essentially a linear discriminant composed of nodes and weights. Here in this diagram, you can find L1, L2, L3 are connected to say another node by means of a weight called W1, W2, W3. Now, when you take a look at this diagram, you find there are lot of inputs from these L1, L2 and L3 nodes. These inputs are going to reach the next layer of nodes based on the link weight. So, the input that arrives to this node is basically a weighted sum of the input and the link weightage. So, it is summation of the input multiplied by the link weight, which is in general mentioned by an equation like this. The theta over here is actually called as a bias function. This bias function, as already mentioned, is used for either amplifying or de-amplifying the input strength. In case if the signal strength is so weak, then the signal will be amplified, or if the signal strength is very high, then it will be de-amplified accordingly. Now, how to model a perceptron? Suppose you are working with respect to say a classification problem. Assume you are going to diagnose patient for a specific type of heart disease. If suppose the patient has the disease, then it is indicated by means of a 1, else it is indicated by means of a value 0. Now, all the records associated to this data are highlighted here. For example, 67 may indicate the age, 1 indicates male, sex, chest pain type, say for example it is 4, then resting BPS is say 120, the cholesterol level is 229 and so on, and finally the patient has been diagnosed to have a heart disease. In the other record you find another patient data and the patient does not have a heart disease. Suppose when you develop a model for diagnosing any new patient who comes to your hospital with respect to this disease, then you can develop a neural network model, train the model with existing records, and when new individual or patient comes to your hospital, based on the model you can decide whether the new patient has got the same heart disease or not. So, in such environments neural networks may be modeled as a classification model. Perceptron are normally considered to be linear classifiers. In other words, they differentiate the classes very clearly or distinctly. So, you can clearly define a straight line as shown in this diagram. Assume this is a scatter plot of the various data available in your environment. Few of the data belong to class 2 and few belong to class 1. Suppose if I am going to make use of a perceptron model for defining the class label, then I can end up with say a linear line, that is a straight line with which I can clearly demarcate between class 1 and class 2 type of data. So, it is considered to be a linear discriminant. So, whenever you have a classification problem which is going to be linear in nature, the neural network will be the best solution for such scenarios. What are the advantages of neural networks? Neural networks, the prediction accuracy is generally high, it is robust with respect to errors as I have already mentioned, outputs are going to be discrete, it is real valued, and sometimes it is even vectors. The evaluation with respect to the learning is going to be too fast, but on the other side the same neural network takes more time for the purpose of learning, and it is difficult to understand the learned functions, and moreover it is not easy to incorporate the domain knowledge. We will understand why these drawbacks are there based on say a model which highlights a neural network model. This slide actually depicts a mathematical way by which you can define a neuron. I told in the beginning of this discussion, a neuron gets multiple inputs. These inputs are received to this or by this neuron using the synaptical link. The synaptical link contains weight. So, consider the inputs as x naught till x n, the weights of the link as w naught till w n, and there will be a summation unit which will take the sum of the product between the input value x and the corresponding link weight. So, this is actually a weighted sum. Now, this weighted sum sometimes may be very high than the threshold, therefore, you should minimize it, or sometimes the weighted sum may be very feeble that you need to amplify it. So, you have a bias function that will either amplify or de-amplify the signal, and finally, the amplified or de-amplified signal must be pushed to the next layer of neurons. So, you have an activation function f that will push all the inputs to the next layer. So, the input to the neuron is going to be an n dimensional vector. So, any data set that you want to provide as an input to a neural network, then you will have to convert that into an n dimensional vector, and accordingly it may be provided as an input. Now, this n dimensional input vector can be mapped to variable y. The variable y can be, say, the output, to which you will have to map the input and the corresponding output. So, normally you will be having a nonlinear function with which you can map the inputs to the corresponding output. Now, when you are going to train the neural network, how this happens? What are the steps involved when you train? The ultimate objective of training is to adjust the weights of the links, and this adjustment will happen until proper training is done. In other words, when your neural network is in a position to classify your data correctly, the adjustment in the weights is going to happen. So, the steps involved are: first you will have to initialize the neural network with initial weights. These weights are chosen randomly. Now, feed the input tuples to the network one by one. In the network, you will be having input layers and nodes in the input layers. So, the inputs should be submitted to the input layer nodes. Then for each and every unit in your network, neural network, you will have to compute the net input as a linear combination of the input and the corresponding weight. Based on the net input, calculate the net output, and you will have to indicate to what extent this output may be quantified using an activation function. Compute the error. The error is computed based on the input and output. Now, this error must be fed back to the system for the purpose of updating the weights. So, the weights and the bias values are updated in each and every iteration, and this is how learning happens. So, whatever I have explained is diagrammatically shown here. So, assume there are 3 layers of neurons. The bottommost is the input layer, the topmost is the output layer, and in between you have a single layer. In reality, you may come up with any number of layers in between the input and output layers. The input, as I already mentioned, is going to be a vector. Now, the input in each and every node is calculated based on the equation summation of wij. Oi is the net output plus the bias function theta. What does this OI indicates is the OI is actually the output to the next layer. The output in the next layer is actually equal to inverse of 1 plus e to the power of minus ij, where ij is the net input in the next layer. Why this output is an inverse of this input is, this function actually can be treated as a squashing function, because inverse of any number will result in a smaller value. So, the input, whatever may be the value, finally, I am going to squash it to a very small value which may be in the range of 0 to 1. In all scenarios, the inputs as well as the weights that are assigned will be in the range of 0 to 1. Once you know the input and the output, then the error between the input and output can be calculated, and the error is going to be fed back to the previous layer. So, when you feed back the error, what need to be changed is, it is this weight and the bias function theta. So, wij is the original weight which will be either added or subtracted with, say, the output at the previous layer. OI is the output at the previous layer. As part of this equation, you have a notation called L, which is called as learning rate, and ERR of j is the error in the next layer. So, when I am trying to propagate my error, I am going to feedback it to the previous layer. Accordingly, output in the previous layer need to be considered for changing the corresponding link weight. Similarly, for the bias function. So, in this fashion the inputs are modified and fed back to the previous layer. Now, when neural networks are used for classification environment, finally you are going to end up with rules. These rules in turn may be used for analyzing or pruning the network which has been designed. So, how this network may be pruned? Now, when you have a fully connected network, it is sometimes very hard to articulate. So, when you take n inputs, h hidden nodes, m outputs, this will result in weights, that is the multiple of the h hidden layer h multiplied by m plus n, where m is the output and n is the input. So, pruning is fundamentally eliminating few links which may result in lesser accuracy during my classification. So, pruning ultimately results in improvement of accuracy. How to extract rules from the trained network? Now, you will have to discretize the activation value, replace individual activation rules by means of cluster average, and thereby you can minimize the number of rules. And when you are trying to enumerate the output, you have to make use of the discretized activation function and also find rules which are between the activation value and output. So, the output must be in the range of activation value and the output. Then find the relationship between the input and activation value, and then combine the above two to generate a rule which provides mapping between the output and the input. What are the various domains in which artificial neural networks or neural networks are used? Science and medicine. In science and medicine domain, neural networks are widely used for modeling, prediction, diagnosis, pattern recognition, etc., etc. For example, effects and undesirable effects of drugs during the early stage of tumors and recognition of early stages of tumors are done using neural network based approaches. Secondly, in manufacturing, process modeling and analysis is one domain where neural networks is widely used, and optimization is widely done in manufacturing domain. Marketing and sales is another well known domain where neural networks is adopted for the purpose of analyzing, classifying and identifying targeted customers. For example, if you want to understand the overall turnover of an individual or of an individual store in a chain of outlet, then neural network may be widely used for predicting what may be the turnaround in the future. In finance domain, for portfolio trading and investment support, neural network models have been developed and utilized widely. In banking and insurance domain, credit and policy approvals, example credit scoring, risk and cost prediction for individual clients are widely used based on neural networks. In security, bomb, iceberg, fraud detections are done using neural network based approaches. In engineering, dynamic load scheduling, pattern recognitions are done. To summarize, neural network is actually a very powerful tool for analysis. Neural network may be widely used for the purpose of classification as well as prediction. When you make use of neural network, though it is complex in terms of computation, but the accuracy of results is going to be very high. So, neural network based models can be widely used for classification domain, and in many scenarios control systems and other applications wherein you require an improvement in terms of the efficiency and accuracy are also places where neural network is widely applied. So, put together, neural network is actually one way by which analysis on data can be performed and various classification and prediction models can be created. Thank you.